What if the world's largest, hottest desert suddenly vanished, replaced overnight by a dense, steamy tropical rainforest? Stop for a moment and really visualize that change. We are talking about 9 million square kilometers of sand, rock, and heat stretching across 11 nations, instantaneously transforming into a new green lung for the planet. This isn't just a local weather shift, this is a planetary atmospheric shockwave. It's the single most massive ecological change Earth has ever experienced. Welcome to a world where geography is turned on its head. Today, we dive deep into one of the most spectacular hypotheticals in climate science. What would happen if the Sahara Desert suddenly became a tropical rainforest? The consequences would be immediate, chaotic, and truly global, affecting everything from rainfall in London to oxygen levels in the air we breathe. Let's unpack the three main consequences of this sudden greening. The first involves the delicate dance of air and water that dictates our global weather. H3.1, the Great Atmospheric Pump Reversal, H3. Currently, the Sahara is a critical component of global climate mechanics, primarily because of what it does not have: water. It's a massive area of intense heat and dry air that significantly drives global atmospheric circulation, particularly the crucial system known as the Hadley cell. This circulation is why places near the equator are wet and places around 30 degrees latitude, like the Sahara, are dry. The heat generated by the Sahara helps push air north and south, influencing the Atlantic trade winds. Crucially, the dust from the Sahara also acts as a natural fertilizer for the Amazon rainforest thousands of miles away, providing essential nutrients that keep that ecosystem thriving. Now, reverse the switch. The desert is gone, replaced by a dense rainforest. This new forest, covering an area the size of the United States, immediately begins releasing trillions of gallons of moisture into the air through evapotranspiration. This massive injection of water vapor fundamentally short-circuits the existing global rain cycle. First, imagine the localized effects. North Africa would experience continuous, heavy rain. Rivers that have been dormant or tiny for millennia, like tributaries to the Nile or the Niger, would swell dramatically, becoming massive waterways, navigable and deep. The change isn't just local, though. The vast increase in atmospheric moisture over North Africa would weaken the high-pressure system currently dominating the region. This shift would drag the Intertropical Convergence Zone, or ITCZ, further north. The ITCZ is the engine room of global weather, and dragging it dramatically would redistribute rain globally. Europe, for example, would likely become much wetter. We might see the creation of enormous, lush grasslands across southern Europe, regions currently defined by Mediterranean aridity. The increased moisture carried by prevailing winds could turn Portugal or southern Italy into environments that resemble Central American jungles in terms of humidity and rainfall. However, the consequences are not all positive, especially across the Atlantic. If the new Saharan forest starts recycling huge amounts of moisture locally, pulling the ITCZ north, it might effectively steal water from other tropical areas. This is known as a climate feedback loop. The Amazon rainforest, which already suffers from deforestation and drought, might experience a massive reduction in rainfall. Ironically, the creation of a massive new green lung, Africa, could turn parts of the world's largest existing rainforest into drier savanna. The success of one ecosystem could spell doom for another, illustrating the precarious balance of Earth's climate. H3.2, the surge of life and the human adaptation crisis. H3, the second immediate consequence of this transformation, would be an unparalleled explosion of life. The Sahara is currently a massive carbon source when it comes to dust storms, but as a rainforest, it would instantly become the single most important carbon sink on the planet. Trillions of trees would sequester staggering amounts of atmospheric carbon dioxide, potentially reversing decades of human emissions within a century. This new biomass would be a massive stabilizing factor for global climate change, locking away carbon and regulating global temperatures. We would witness a biodiversity explosion. Plant life would adapt and evolve rapidly in this new environment. Animals, previously isolated to pockets of the Sahel or North African coastal zones, would migrate rapidly. Gorillas, chimpanzees, elephants, and leopards would find a new, expansive habitat, creating an ecosystem rivaling the Amazon or Congo basins in scale and complexity. This is the good news. Now, let's look at the immense human cost. Millions of people, primarily nomadic or semi-nomadic tribes and communities, currently live in or around the Sahara. They are genetically and culturally adapted to high heat, low humidity, and the scarcity of water. Their entire way of life is built on surviving aridity. A sudden shift to a tropical rainforest environment would trigger a massive humanitarian crisis. These populations would instantly face overwhelming humidity, constant torrential rain, and an explosion of disease vectors. Malaria, dengue fever, and unfamiliar waterborne pathogens thrive in dense tropical environments. The construction and infrastructure of existing Saharan communities are not designed to withstand perpetual moisture and jungle growth. Homes would rot, crops adapted to arid lands would fail, and transportation networks would be quickly swallowed by the jungle. The result would be one of the largest climate refugee crises in human history, forcing millions to migrate north towards the Mediterranean coast or south into the already crowded Sahel regions, seeking environments that can physically tolerate and manage. Furthermore, managing this new rainforest would be a geopolitical nightmare. Countries currently holding vast, relatively worthless tracts of desert would suddenly own the world's most valuable resource, the largest, most effective carbon sink. Ownership disputes, resource wars over timber and minerals, and massive international efforts to protect the biodiversity would dominate global politics for decades. Age 3-3, the volatile, unforeseen consequences. Age 3 greater than our final category moves into the genuinely unpredictable side effects that chaos always brings. When you rapidly transform a planetary system on this scale, the side effects are often more profound than the intended change. One major consequence involves the very air we breathe, oxygen levels. Rainforests are incredibly efficient at photosynthesis. While oceans are the biggest long-term producers of oxygen, a rapid, massive expansion of terrestrial biomass would lead to an immediate, measurable increase in atmospheric oxygen. Current levels hover around 21%. A vast new rainforest could push this significantly higher, perhaps toward 23 or 24%. Well, this sounds great. Higher oxygen levels have dramatic consequences for thermodynamics and combustion. The world would become inherently more flammable. Natural disasters, particularly lightning-induced forest fires, would burn hotter, spread faster, and become virtually impossible to contain. The new Saharan rainforest, dense with new growth and subject to intense tropical storms, could become a massive fire risk, ironically creating its own destruction. But the most spectacular, if terrifying, unforeseen consequence involves geology. We often forget that the Earth's crust is surprisingly flexible. We are talking about replacing millions of cubic kilometers of light, dry sand and rock with an equivalent volume of dense, waterlogged soil, saturated with groundwater and supporting colossal biomass. That is an enormous amount of weight added instantaneously to a vast continental plate. Geologists refer to this as crustal loading. We see similar effects when large ice sheets form or disappear. This sudden, massive change in weight distribution across the African plate could reactivate ancient fault lines. We might see an increase in seismic activity, potentially triggering earthquakes in regions previously considered stable. The entire geological stress balance of North Africa would be violently disrupted. Furthermore, the new constant heavy rainfall would lead to massive, continuous erosion, fundamentally reshaping the coastline and moving colossal amounts of sediment into the Mediterranean Sea and the Atlantic Ocean, potentially impacting marine ecosystems and dramatically changing ocean currents. The vision of a green Sahara is undeniably utopian. It offers the planet a fighting chance against runaway climate change by giving Earth its greatest ever natural cooling mechanism. But this hypothetical transformation underscores a crucial, humbling truth. The stability of any system, no matter how harsh, is preferable to a sudden, chaotic change. A green Sahara would offer redemption for the planet, but it would demand a monumental cost in human displacement and adaptation. It would be a new paradise built on a foundation of global volatility. The Earth is not merely a collection of isolated ecosystems. It is one interconnected, highly sensitive machine. Pulling one lever, even one as massive and dramatic as turning a desert green, shakes the entire structure.